Hello, everybody. It is Saturday night at 10 o'clock Eastern Time. I am Chris Weuve, and this is Starfleet Tactical. I am busy not speaking for my employer, but I am speaking with Sean Barnett and Peter Gold, and we're here today to talk about some ship tour stuff. And at some point, we'll have to pull LYSSA into the screen and talk about whether anything has happened in her life recently, because we haven't talked to LYSSA for a while. But she's actually, I think, off doing something real quick after she launched us, and I think she's dealing with the dog, because there was a barking dog in the background before. So in any event, it's good to have you both back on. We called an audible last week and talked about the motor vessel Dolly and the collision and sort of implications for science fiction. And I want to go back to that topic at some point, because there's a lot of really interesting things there that one can say about ship handling in science fiction, and how do you get that sort of same feel, and do you want that same sort of feel? But we're not this week. So Peter, how have you been?
Pretty good.
Okay. So that's good. Life in the merchant marine is going well.
Yep. Still employed. Still haven't heard back from the guy that's supposed to come back and relieve me. Is still waiting on the Coast Guard for his paperwork.
Is this normal?
Somewhat. Coast Guard is seriously understaffed.
Yeah, they're small.
Yeah.
They're now, most of my experience with most of my experience was post 9/11, but it wasn't unusual with the Coast Guard to say, like, have somebody in your office call me, and the answer is somebody in my office. I am the office. It's just me. I don't even have a secretary. Okay, that's cool.
If I remember right, I think the Coast Guard is smaller than the NYPD by a little bit.
I think it at least was at one point. I don't know if that's true post 9/11, but yeah. And not as well armed. I'm actually not joking. Although the Coast Guard has the ability to go out to long distances. So okay. Okay. So let's see. What have you been up to, Sean?
I've been watching basketball games, as you can guess by my attire. My Purdue Boilermakers won tonight, and they are headed to the NCAA finals on Monday night. So it's a happy occasion.
Who are they playing?
Well, we don't know yet. UConn and Alabama are playing tonight. UConn's favored, but I haven't checked in to see what's happening with the game.
Okay. Well, what's going on with the women's side?
Women's side, your Iowa Hawkeyes are in the finals. They beat UConn on yesterday night, and they are playing South Carolina in the finals tomorrow. And South Carolina is very, very good, so it's going to be a challenge for the Lady Hawks. But we will see.
Well, that's good. As Sean knows, I'm pretty sure. I'm having a hard time sort of figuring out the family tree, but I'm pretty sure that one of Caitlin Clark's aunts was in my graduating class, because we went to the same high school, and I actually knew her grandfather because her grandfather had an office right next to where the debate team had its office. So I literally saw her grandfather every day for 4 years.
I got to run down and get the door. I'll be back in just a minute. Sorry.
Roger that. So, LYSSA, are you available to come on for just a second?
Hi.
So what have you been up to, LYSSA?
Apparently getting engaged.
Oh, really? Does Robert know?
Yes, he does. He's the one who brought the ring to me. It was really cute. He brought it to me in an Easter egg and said he'd save me a special one.
That is pretty cute. So for what it's worth, we knew this last week because LYSSA had just gotten back and was still dealing with kids and stuff like that. And so she didn't do the show last week, but she did flash the ring at us. And we said, okay, we're going to keep this as a secret until you had a chance to actually tell your story yourself. So congratulations from all of us. I'm glad that you're happy with that situation. And that was a really weird way to phrase congratulations, but
You're good. We're all awkward neurodivergent nerds here. It's okay. Yeah.
Okay, let's see.
Okay, back.
Okay, I was just taking a look real quick at if anybody was saying anything. All right, so let's go ahead and start. We are talking tonight about the USS Wisconsin and the tours that we did. And so basically what it boils down to is Peter and I and some people did a tour in January, and Sean and I and Mike DiCarlo did a tour in March. And so this is photos from both of them put together, and we're going to do our standard thing. We're going to talk about the ship. We're going to talk about it in science fiction terms along the way. And, maybe there'll be a surprise at the end. Who knows? So here's the somewhat Chris-centric schedule. I talked with Pat, by the way, today, and Pat is learning how to fly his Starship, whichever flavor of Airbus it is. So he's currently in Atlanta doing simulator stuff. Even as we speak, he's studying because they're doing hardcore simulator stuff and then studying at night to figure out where all the buttons are and stuff like that. So that's what he's doing. So next week, I expect to do a show. The week after that, I expect to do a show. I'm going to be in Iowa for both of those. And then there's 4 weeks of no shows because actually on the 27th, I'm going to be with Sean. And we're going to be about that. We'll probably be done playing Ogre by then because I think the Ogre session won't go that late. But it's actually going to be a late night because we're not going to start until 3.
All right, it's okay.
But that's the person who's hosting is unavailable before that. So we're going to do that on Saturday. The following, then I go into the period where I'm actually doing work-related stuff, and it is up to my eyeballs. They said that the building closes at 11 p.m., so they'll kick us all out by 11 p.m., starting at 8 a.m., and that includes Saturday. So Saturday night, I'm not going to have any cycles to put together something, and I can't guarantee the internet connection where I'm going to be at is sufficient for doing streaming because I haven't tested it, et cetera, so just not going to do it. Then I come back. I'm only back in town for like 4 days, and then I immediately go off to Marcon. And so I will be in Columbus with my brother Delon, who is here tonight, and some other people. So I'm going to miss that. And then on the 25th of May, I should be back. I didn't change the Exordium thing. I do want to do the read along. I kind of concluded I got to hold off on that a little bit longer again. I was getting ready to start it. In fact, I was actually thinking about starting the audiobook again so I could get back into the Exordium frame of mind. But then I realized there's a reason why I shouldn't do that. And that is once I start doing Exordium stuff, I'm probably going to be living and breathing Exordium it is my favorite series after all. For some period of time, and I actually owe Chris Carlson a game design. And so I decided to not go trigger the 6 months of obsession with Exordium until I'm ready to until I've met my commitment to Chris and Larry Bond. So that's what's going on with that. So as always, my employer will disavow all knowledge of my actions. I'm sure Sean and Peter's employers will also. Nothing I say should make you not enjoy something you currently enjoy. And, I'm pulling photos from a lot of different places, but the purpose of showing those is to offer a critique of the photos and for educational purposes. So I believe in fair use. Okay, so this is the latest in a series of ship tour stuff. We're going to look at the USS Wisconsin, an Iowa-class battleship that, like I said, I toured in January and in March. And so here are heroes. The top row of pictures is from the January trip. The bottom row is from the March trip. So in the top row, you have me, Heather, Jacob Hollow, and Tom Pope. And then in the second picture, you can see there's people in the background. Jacob and Tom is in the background, but then Peter's on the far right. The second picture, that's one of the docents there we were sitting in the captain's cabin. And there's me and Greg Whitaker, another BU9 member. And I think next to Greg is somebody who was just some other person who was there, not one of our group. On the right-hand side, you see Greg, myself, Mike DiCarlo, and Sean. And so that's actually a composite photo. I wish they wouldn't do that because they can actually take you. They could do it with a picture of you at the backdrop, but they do the Photoshop thing and sort of put you in at an angle that you're not at, which is mildly annoying to me, at least. Okay, so here's the Iowa. Now, the thing to keep in mind about the Iowa class ship Wisconsin, here's the Wisconsin. The thing to keep in mind about all these Iowa class battleships is that they were in and out of commission. And even when they're in commission, they get refits. Like during World War II, all the ships got refits all the time. You'd go in and they've got new weapons or they got new systems. And it's like, oh, we decided that you need more anti-aircraft guns. As a general rule, every time you went in, you got more anti-aircraft guns. Sometimes they ripped the old ones out and gave you new ones, like heavier caliber ones. Sometimes they just added some. If the war had gone on to like 1950, there wouldn't have been any deck space left because it would have been totally covered by anti-aircraft guns. So the Wisconsin was in commission from 44 to 48 and from 50 to 58 for World War II in Korea. And those, those were sort of like the normal refits. And then from 86 to 91, she got a very extensive Cold War refit. And by very extensive, I mean pulled off 5-inch turrets, built new decks, put on Tomahawk and Harpoon on decks that weren't there beforehand. And so the superstructure looks a lot different in that time period. That is a picture of her circa that time period for the Cold War refit. If you know where to look, you can see the Slick 32 system, and you can see the Sea Whiz that they added, and you can see the helicopter deck at the back. You can't really see you can kind of see the Tomahawk launchers, but I should have put in a side-by-side comparison to get a real good view of the Tomahawk launchers. So, Peter, Sean, any thoughts about what I've said so far?
No, it sounds great. What you might add is that the New Jersey, the sister ship to the Wisconsin and the Iowa, was served in Vietnam. And
yes,
was recommissioned in the 60s and served in Vietnam, I think, for a year in 1968, if I remember right, and then was brought back out of service, but then was brought back into service with the other 3 Iowas.
Yeah, that's a good point. It actually got a little bit of extra service there. One thing to call out, so look at the beam of that ship, 108 feet, 2 inches. How wide is the Panama Canal locks at this time?
It's either 110 or 109.
Yeah, 110 it was the number that I've always heard, but I've never been through the canal, so maybe you would know more than me on that. I'd always heard 110, and so getting her in was a very, very tight fit. There's some photos of an Iowa-class ship going through, and it's a very tight fit. Lots of scraping along the way. The new locks are bigger than that, but at the time it was, that was a constraint. And so that had some interesting follow-on effects because you've got the size of the lock. You kind of want a certain beam to length ratio, and the locks have a maximum length too. And I don't remember the length because the beam is really the constraint there. But it basically boils down to that's as big a ship as the U.S. Navy was going to build that could get through the canal. If you build bigger than that, you can't get through the canal. And so the Montana class, the never built Montana class, which was going to be a 4-turret ship with 16-inch 50 guns on it, those ships were not going to be Panama Canal capable. Now, at the time they were talking about building new locks, bigger locks, But that project got put on the sidelines, and that actually didn't end up happening until the 21st century. And now it looks like it's all for naught because they're having problems with the water level in the canal. And so the canal traffic is way, way down. So,
well, yeah, because of the water, they can't afford to put the ships through.
Yeah. Because basically there's a certain amount of water. Every time you cycle through, there's a lake in the middle. And every time you cycle through, you lose however many hundreds of thousands of gallons for every ship that goes through. And it's problematic because there just isn't enough rain. And it's also, I want to say that lake is also the water supply for a bunch of people. So it's really a problem. The drought is really causing a problem there.
Yep, that's two choke points that are in trouble at the moment.
Yeah, the other one being the Suez Canal, which is right next to a bunch of crazy terrorists with missiles.
Yeah.
I was listening to something earlier today about exactly how many missiles the U.S. Navy has expended, and the answer is, oh my God. So it's like on the order of 100-ish.
A subject for another day.
A subject for another day. Another subject for another day is, what was I going to say? There was something I was going to say about battleships and choke points and stuff. I can't remember what it is. That's okay. It's a subject for another day. Okay, so here's the general layout, and I called out a few things. Don't be confused by the fact that in retrospect, I should have used blue for the stuff that I was highlighting because there are some red circles on the bottom part that I did not put there. So just ignore the plan view, look at the side view. And the thing to take away from this on the side view here is you've got several gunfire directors. And then you've also got an area of superstructure that was rebuilt for the 1980s upgrade. So that rectangle is the area where they ripped a bunch of stuff out and put new stuff in and then put some Tomahawk launchers. And Tomahawk's a big weapon. Tomahawk is the smallest non-ballistic missile in the fleet, or the largest non-ballistic missile in the fleet. It's big enough that the Navy has a hard time with cranes that are capable of moving it. You have to use special cranes to do that. The gunfire directors are the two taller ones, the one forward and the one back, are Spot 1 and Spot 2. The others are marked Sky 1 through 4, and they're sort of the secondary directors, and there's one forward, one aft, and one on either side. If you think back 50 episodes maybe, to the discussion that I had about naval doctrine, and I gave you this example of doctrine from the doctrine manual in the 1940s. The doctrine manual talked about splitting the anti-aircraft fire into 4 sectors of 100 degrees each, which means there's overlap between the sectors. And each one of those sectors would be under the control of one of those fire directors, those four gun directors around the outside. And that's because those are the ones that controlled the 5-inch 38 turrets that were all over this ship. And then as a general rule, Spot 1 and Spot 2 controlled the main guns. But, as we're going to see in a moment, they could move stuff around if they needed to because of damage or whatever. Okay, so here's a picture Sean took, a couple of pictures Sean took, a Pier side. So I'll note that one on the left, that's almost exactly the view you get if you come out of the parking garage of the hotel I stayed in when I visited the Wisconsin, not this past January, but the January before. I was at a thing down there for a business meeting, and I stayed in a hotel. And is that in January? No, that wasn't. I'm sorry, that wasn't in January. That was in October or November, that time frame. And when I came out of I got there not having seen the ship because I got there late enough at night. It was dark, and I was busy making my turn, and so I didn't look down that direction. And when I came out of the garage, I turned left to make sure there was no traffic, and there's the battleship. I knew I was close. I didn't know that I was in danger of the battleship running me over. So it's big. Okay, so here's some topside stuff. We've got a picture of Greg's head standing in front of one of the turrets. And then on the right-hand side, we got a picture of one of those 5-inch 38s. So we've got the 16-inch 50 guns and the 5-inch 38. So what do I mean when I say 5-inch 38? What's the 38 mean? Or the 1650? What's the 50 mean? Those are the length of the barrel measured in calibers. So 16-inch gun, the barrel is 50 times 16 inches. 5-inch 38, it's 38 times 5 inches. And I'm not going to do the math in my head, but you can get an order of magnitude estimate. I think
800 for the 16-inch guns.
Yeah, 800 inches.
Inches.
Yeah, which works out to like 80 feet or something like that, or 60 feet. I forget. I've got it listed. It's too late in the day to do math. So the Iowa class had 16-inch 50 guns. The preceding North Carolina and South Dakota classes had 16-inch 45 guns, which meant it fired a slightly different shell and to a different range. Even though they were both 16-inch shells, they were different shells, but part of that was the Bureau of Ordnance was coming up with new shells, including a new super heavy shell for the 16-inch 50s that gave increased penetrating power. And that gets into this interesting discussion about, the U.S. metric was your armor had to be able to defend against your gun at a certain distance. And, then it turned out when they made the gun more effective, it no longer met that criteria. And as a result, some people said, well, that means it's not a battleship. And it's like, look, there's no law. It's not the law. It's not a law of physics. It's not even it's not a law of man. It was a rule of thumb. That was a design guideline. It was not a classification guideline. It was a design guideline. And so, yeah, just get over it, people.
Yeah. It's not like the Washington naval treaties with the
right
heavy and light cruiser specs.
Yeah. I mean, that's a fantastic example, because with the Washington Naval Treaty, the Washington Naval Treaty, or actually might have been the London Naval Treaty, that essentially created the light cruiser as heavy cruisers had guns up to 8 inches, but light cruisers couldn't have guns bigger than 6 inches, approximately. I want to say there's a decimal point in there. And so you ended up with these ships that were the same size, but one of them would be covered in 5-inch guns, and the other one would be covered, because we went with 5-inch guns frequently because we made a shitload of 5-inch guns and we could use the same ammo. So you'd have something, I think the Cleveland light cruiser was like nothing but 5-inch guns, if I remember correctly. And then you had these heavy cruisers that had 8-inch guns. And the only reason they existed was because of the Washington Naval Treaty. And I'm actually going to do a show on the Naval Treaty and the distorting effects it has. I've kind of mentioned this in the past, but it controlled the order of battle. It controlled the resources that you had available when you're planning tactics and planning strategy. But tactics is very much technology dependent. It's very much order of battle dependent. And so as a result of that, it led to, you weren't thinking about a carrier-based force because you didn't have any carriers. You only had a handful of them. And so it was only after the naval treaties went away and we decided to turn all the knobs to 11 on our factories that it started to make sense to start thinking in terms of, maybe I can fight this war with carriers. And that's even leaving aside the idea that nobody had actually done that before, so people didn't have an idea of what the effectiveness was, right? So I'm going to do a show on that at some point. And we'll talk about the treaty that bans cloaking devices in the Federation. And yeah, okay. All right, so here's the Tomahawk launchers. So the Tomahawk launchers are actually kind of funny in that they shoot over the ship. What do I mean by that? I mean, the part where the blast comes out is on the outside of the ship, and then they raise up and they shoot over the ship. At least the forward set of launchers do. The back ones are kind of set up differently, and I don't understand why they set them up the way they did. And so why would you do it that way? And the answer is because you're lighting off a rocket motor, and this way the rocket exhaust goes off the side of the ship. It doesn't hit the deck. It's primarily going off the side of the ship. Although I will note all that non-skid that's there on the deck, you can sort of see that it's rough. That's because it's non-skid. All that non-skid is going to get pretty jacked up, even by being in the neighborhood of a rocket going off. But, you know, if you're launching your Tomahawks, that's a small price to pay, right?
Yeah.
So, all right, let's go to the next one. And okay, so here's the Wisconsin again, another picture. This is actually a picture of the armor pattern. I'm not going to get into the armor pattern. What I want to emphasize here, and I probably should have just blown this up. In fact, I think I'm going to redo that so that when I archive this presentation, I think I'm going to do that. One thinks of the turret as this thing that's on the deck. The turret is actually a 5 or 6 story tall building that rotates. The entire thing rotates, and it extends down into the powder room, into the magazine. And you move stuff from the powder room, from the magazine, by basically just sort of moving it over to get it into the part that rotates. It's especially true of the shells.
Yeah. The Battleship New Jersey YouTube channel, I believe, has a video explaining that whole process.
Yeah, and it's a fascinating process, and they're manhandling all this stuff. It's all done with people. It's not, you know, people with tools, but people manhandling stuff around. There's like 70 people in that turret working. And that entire thing rotates, and it's, like I said, it's basically a 5 or 6 story building. And the part that's above deck is just the penthouse. Now, on the Wisconsin, you can't go see that area. And I don't think you could on the New Jersey either. The more modern ships, you can't get to it, but you can see it on Alabama. You can see it on Massachusetts.
Yeah.
And it's worth tracking it down and taking a look inside and sort of seeing how it works and all the rest of it. It's cool.
Yeah, absolutely. A trip to the Massachusetts is well worth taking for anyone who has the ability to do that.
Yeah,
lots of stuff.
And I noticed I've done both Massachusetts and Alabama, and they're different. They are different ships, and I don't know whether they're different shipyards. I just haven't bothered to look it up. I once was on USS Porter, DDG 78, and then I did USS O'Kane, DDG 77. Right, so they're right next to each other. They are the same version of the DDG, but you could see the differences from the different shipyards in terms of where they put doors and stuff like that. And if you go to the Battleship New Jersey YouTube channel, you'll discover that the blueprints are a lot fuzzier than you would think, because it might be that there's a guy who's doing one side of the bulkhead and a different draftsman who's doing the other side of the bulkhead, and they don't necessarily agree on where the door is. And so some construction manager gets to decide where to put the door. And that's not even getting into things that were designed one way and then implemented another way just because they were making changes on the fly to make improvements and stuff, or things that over time changed because they they said, okay, we need this space more and we need that space, or what if we move this over here, or stuff like that, right? It's just like your house, it changes over time. And so it doesn't even get into all of that. Now, back in the day, they weren't even necessarily tracking this stuff. It just sort of happened, and you just had to sort of figure it out. You had to know your ship. My guess is in the Starship Enterprise, everything is meticulously documented in their computer system. And you can figure out exactly when a change was made and why it was made, et cetera, because you just pull up the record. That's not how it worked on these ships. How does it work in the merchant marine, Peter? How good is the documentation on things like that?
Depends upon the ship.
That's the answer I was expecting.
Yeah. So every single, no, I shouldn't say every single. Any significant change that might have an impact on firefighting, life and safety, major machinery, has to go through class and flag state approval. So with a U.S. ship, it usually goes through the American Bureau of Shipping's engineering department, and also through the U.S. Coast Guard.
Okay.
But they only check the plans that are submitted to them. So if an owner decides that they want to do it differently on the next ship 5 years later, they may still submit a different set of plans. Okay. So I don't know when they shifted everything over to CAD/CAM, computer aided design. After I graduated, I'm pretty sure. But most of the ships I've been on have had paper blueprints that have been then manually scanned in, not CAD drawings.
Yeah.
Military Seal of Command had a ongoing problem with trying to maintain a change database, and it slowed things way down, to the point that trying to get a change made, if you get a pump that's no longer being made, you had to go through Washington, D.C. for approval. And they had to approve it for every single ship. And you had a plan of when that was going to happen.
Wow.
Whereas you get on a regular commercial ship, as far as I know, as long as it meets, it was a class approved, flag state approved pump. Here's 5 pumps that all meet the same. As
long as it meets the requirement.
Yeah, and they've all been approved by class and flag state, Coast Guard and whatever. Doesn't matter which one you put in.
I know that during the war, and they did this with both ships and airplanes, because they were turning the crank, they decided that it was easier to keep turning the crank and then take it out and rip out stuff that they had just installed. So they literally were doing things like with airplanes, they'd fly it to another field. They'd fly it from the factory to another field, and then they'd start cutting holes in it to add stuff, like maybe another turret. And they did the same thing with ships. They would then say, okay, we're gonna take it to the other side of the shipyard. Came off the ways here. We're gonna take it to the other side of the shipyard, and we're gonna start doing hot work to cut things out and put new things in, etc. Because it was so much easier to manage the problem that way than it was to try to document everything and keep it straight and change the production process.
Yeah, that happens with Korea and I believe Japan too. If you order a ship, as soon as they cut steel, you're committed to what that design is. If you want to get a change made after you actually have possession of the ship, you can take it to a shipyard and they'll make the changes. But because they set up their production schedules, this is what we're going to do. And they'll try and work with you, but if it's going to add time to the production line, no, dude.
Yeah, I can understand that.
Yeah.
Makes sense to me.
Yeah. So, literally the story is that, you go into a Korean shipyard and they give you a set of plans for a container ship, and your choices are, what color do you want the interior? What color do you want the interior painted? Yeah. And what color chairs? It's literally about the only choices.
Racing stripes.
Yeah. Yeah.
So for what it's worth, I remember why I didn't do the exploded view of that turret, and it's because of this illustration. And so that's basically what I'm talking about. That core, the anything that looks circular there, right? Anything that looks like it's part of a cylinder rotates. And you've got powder storage, ammo storage, all that stuff there. The powder in this illustration is orange, and the shells are green. And you move it all onto the turret, and then you've got elevators that take it up to the top.
Yeah.
And you're moving around 2,700-pound armor-piercing shells.
Yeah, with basically like wrapping a chain around it and sort of manhandling it. You kind of walk it. It's really amazing, and you're doing it. You're moving it from a part that isn't moving to something that might be in motion. It might be rotating. It's really just amazing. Okay, so let's talk about fire control, because both of you guys got to see me geek out over fire control. Because when I'd done the Wisconsin the previous time, I had sort of been, I sort of kind of like, wait a minute, what? And it didn't quite click what I was seeing. I knew fire control was important. I didn't understand what I was viewing, and then I went, oh shit, I got to go back and take a look at it. And so I was geeking out over this. So I'm going to show you a couple of different illustrations here. Basically, there's two illustrations here. The one on the left, I've marked for like the things that I know that there's more than one, because I know that like the Massachusetts has 2 combat information centers. There's a backup. I assume that that's the case on the Wisconsin, but we couldn't get into the Wisconsins. Note there's a combat information center, which is about air defense. That's the World War II era command and control space. And then there's a combat engagement center where they converted the Admiral's stateroom to control Tomahawk and Harpoon and Sea Whiz and the electronic warfare stuff. And you could get into that. And there's going to be some pictures of us being in there. But so there's 2 combat information centers. There's 2 battery plots. Which is like the secondary battery plot, which also does air stuff. There's 2 primary battery plots that are mainly about the main guns. You've got 3 turrets. You've got 10 5-inch 38 turrets in the World War II configuration. And you've got a total of 6 gun directors. The illustration there is the Mark 37. And then up above, I've added a picture of the Mark 38. The Mark 38 is the one that controls the main guns. And so what you've got on the Mark 38 there, the things sticking out are basically a binocular scope. It's to get a lot of parallax. There's optics at either end, and they can do ranging with that. And then on top is a ranging radar, so that you can get the range from that radar on the top also. On the right-hand side, you see a similar schematic that shows information flows between all these different things. You've got stuff going to CIC, and then it goes to here, and then it goes to there, and it eventually has to get to the guns. So the guns are pointed in the right direction at the right elevation for a particular range. You've got the stable vertical that actually tells you whether what the orientation of the ship is. And so that's part of the process of when you pull the trigger, it waits until the ship might be rolling. And the stable vertical tells you whether it's in the right orientation. You pull the trigger and hold the trigger, and then the gun will fire when it hits the right part of the roll. But it's calculates that and adds that information into all the other computer type stuff that's setting all the stuff. And so on the right-hand side, we've got yet another illustration of all these different information flows. This one actually has a little bit more information about what type of information is going on any particular circuit. On the left, you've got the fire control computer where you're actually setting ranges and stuff like that. And it's all mechanical gears. And it was accurate enough that when they brought the ships back in the 1980s, they thought about, should we replace this? And they concluded, no, this is as good as we can get. We could spend millions of dollars recreating this as an electronic system, as a computerized system, and it won't be any more accurate. So let's just stick with this. So keep in mind all these circuits. Look at all the circuits there. Keep in mind all the information flows. Things are going through various things. We see it here too. There's lots of information moving around. So, at least in theory, you might have a situation where, okay, I've got spot 1 that's controlling the guns, but the ship has changed orientation, and now spot 1 doesn't have a good view anymore, but spot 2 does. So how does spot 2 now talk to the guns? And which guns is it talking to? What if I want to split my fire? Right? What if I'm in an orientation where I want the aft turret to be firing at one target and the 2 forward turrets to be firing at another target? How do I do all that? And the answer is you do it with this thing, the fire control switchboard. And so each one of those handles is a rotary switch that has multiple options that you can select to set up the circuit. So you go through those things and you set the switches in particular ways, and you're defining how the information flows to get to the guns. Spot 1 talks to this, which talks to this, which gives the information to the gun. And so you've got people that have to be able to change this on the fly in combat as the situation changes. When I finally realized what I was looking at and what they were doing there was this little bruise on the bottom of my jaw from my jaw hitting the floor. Because I thought that was pretty significant. Nowadays, all this stuff is done electronically, right? You wouldn't have all this stuff. A computer would be routing all the information as is. Probably wouldn't even ask the human as to what it wanted to do. It would just pick the appropriate thing given what the angles were, etc. Because I mean, this is similar to Spy 1 on an Aegis ship or the surface search radar on an Aegis ship, feeding into the Aegis combat system, feeding into this part of it, because the Aegis combat system is a federation of there's like 4 different components, and it passes information through it, and it's got stuff from various sensors, etc. All this stuff is now done in a computer. Back then, somebody had to turn one of those rotary switches to say this computer talks to that gun.
But it does provide an impressive level of flexibility for 1940s fire control.
Oh yeah. It's phenomenal. And the thing is, there's multiple walls like this. In fact, I think if we go to the next one. Oh, no. Did I not include it? There we go. There's gunnery plot. So I can't remember which. I think the one on the left is primary gunnery plot and the one on the right is secondary, but if I remember correctly. But one of them had basically 1.5 walls covered with those switches, and the other one had 1 wall covered with those switches, if I remember correctly. So there's a lot of switches. And keep in mind, there's redundancy in all this stuff. So you've got like another set of rooms on the other side of the ship that are doing the exact same thing. And so there's got to be some way of saying, okay, that room's destroyed, so don't use it anymore. Use the other one instead. And I couldn't set this up. I don't know how they handled that part of it, but it's just phenomenal what they had there. Okay, so this is some pictures inside the Combat Engagement Center. Used to be the Admiral's stateroom. That's what we're looking at down below. You've got 2 combat information centers. At least I assume the Iowas have 2. Those are the 1940s era space focused on ship defense and offense. And then you've got 2 main gunnery plots. Those are all about firing the guns. And then that's about the Combat Information Center is a space that's about deciding what to shoot and how to shoot it. Gunnery plot is about executing that decision. Secondary gunnery plot is also about executing that decision, but it's probably concentrating on the 5-inch 38s, which usually meant it was concentrating on air defense. And then the Combat Engagement Center, there's one of those. That's a 1980s era thing that we're looking at down below, that controls the added on stuff. That center picture is the Tomahawk control. I'm sorry, not Tomahawk, Harpoon control panels. And they're like that, probably like that by like that. So they're probably kind of heavy, but that's it. That's basically it. You've got some inputs and then you've got some wires coming out, but that's the computer that calculates all the Tomahawk stuff. You enter the information on it. I'm sorry, I keep saying Tomahawk, Harpoon. You enter the information on it and then you press the go button and it goes. And as a nice touch, they had manuals for the Harpoon computer game sitting on top of the Harpoon fire control stuff. So for the Wisconsin, they play a little audio tape with some sound effects, and they've got spotlights that shine down on the seat of the guy who's talking. And they took several days worth of stuff and sort of crammed it into one 5-minute engagement. None of that stuff happened at the same time as sort of one continuous thing. And they played fast and loose with the timeline, because for some of those things, like they just sort of ignored time of flight of missiles, for instance. Oh, we fired. Oh, we got a hit. So thoughts on this, gentlemen?
No, I believe the presentation is also available. Somebody videotaped it and put it up on their personal YouTube channel. Oh,
that would be cool. Yeah, you can probably find that.
Yeah. I found it when I was researching back in January to make sure I had some ideas of what we were going to be seeing.
Wisconsin's got a pretty good show. They've got some video stuff set up in various places, and they do a pretty good job. I'm happy with that. It's well worth the tours. It's well worth paying the money for the tours.
In thinking about these spaces where they're doing the fire control, it is interesting to think about the number of people they used to operate the systems in the 1940s and in the the 1980s, 1990s, and everything on the ship in the 1940s is very manpower intensive, with people operating in switches and such. Then when you get into the later decades, it's you're doing a lot more with computers and electronics, although there still have a fair number of people that are involved in operating the weapons even in the 1980s.
Yeah, in fact, one of the things that has always surprised me going to see is how many people you can cram into a very small room. I mean, the X-ray module on Nimitz class carrier, so it's the ASW module, is probably half this, a third the size of this space here, probably about a third the size. And I remember one point looking around and counting, and there was like 17 people in the room, 18 people in the room. That was in a room that's about the size. It's about the size of my living room, dining room combination here. We had 18 people in the room, and there's gear, right? There's several workstations. There's a table with a chart on it. There's all sorts of stuff. It's not like it's an empty room. And we had everybody crammed in this room because that's where all the exciting stuff was happening at the time. So gunnery plot, we already looked at that. This is the machine shop on the right-hand side in Broadway. So Broadway is this long corridor. All the battleships have Broadway. Broadway is a long corridor, open for 400 feet, 300 feet-ish down the ship. Above the damage control deck, because below the damage control deck, you don't have interpenetrations between watertight compartments. That means that if you want to get from one compartment to the compartment next to you, you go up and over and back down again there, because there's no doors going through. That is different than merchant standards. Merchants will frequently have watertight doors, But if you're dealing with a situation where somebody's going to be shooting at you, doors can be sprung. So it's much better to just have a bulkhead. If you look on the left-hand side on Broadway, you can see that yellow rail at the top. That is a monorail. If you look on the right-hand side, you can see the monorail with the little thing on it. You can use that to move generators, other big pieces of gear, and shells, because you've got two magazines that are about the same size, but one of them is next to two turrets, and one of them is next to one turret, and two turrets can fire shells at twice the rate of one turret. And so it's conceivable that you might find yourself in a situation where you have to move stuff down from one magazine to the other magazine. So you'd have to pull it up, move it across, drop it back down. I don't know when they're putting shells on board the ship. My guess is they also have to run shells through Broadway when they're putting stuff through the ship.
I don't think so.
You don't think so?
No.
That's entirely possible. I wasn't paying attention to that part.
Yeah, because there's a hatch. There's up forward near the officers' dining area, officers' wardroom.
Did you see a hatch aft?
I don't know if I saw a hatch aft, but there was a hatch out on deck for number 3 turret that lets you load down into the magazine that way.
Okay, could be. That's what I was thinking. I missed that. So
yeah, but I'm not 100% sure if that was for shells or if that was for powder or powder and shells. Probably, I think it was just shells, but there would have been another one for powder.
Yeah, that makes sense, because you want to have as much of that stuff going in parallel as possible, because you want to be able to reload as fast as possible.
Yeah.
So, and this machine shop had a bunch of gear in it that was just basically, a lot of that stuff is 1940s era gear, and it, if you want to pull that out of the ship, you're going to be cutting holes in the decks to lift it out with a crane, because it ain't going anywhere. That lathe there is way bigger than you think it is if you haven't been in the same room with it. It was a pretty good size lathe.
Yeah, I think it's bigger than the one we had on the Martin.
Yeah, it was huge.
Yeah.
Oh, and you can also get a feel for, like, those are controls that are just in a passageway, right? And you see firefighting gear and all this other stuff. You look at U.S. warships, and they generally look like that. There's shit all over the place, and there's no fault ceilings. You can see all the cable runs on the ceiling, and everything is available. Everything is immediately accessible. Everything is very obvious. You look on a Russian ship, and it's all behind panels. There's very little damage control equipment, and they've got drop ceilings. Drop ceilings are A, something that can burn, and B, hide damage from you, right? And you have to pull that shit down if you're doing damage control anyway to fix stuff. And so let's just not have it. And like on U.S. Navy ships, there's axes and hoses and everything else just in the passageway. In this case, we've got some controls. I want to say it was controls for some pumps, if I remember correctly.
Pumps and mostly valves.
Valves.
Mostly remote operated valves.
And that X there means material condition X-ray, which means basically it says normally this valve should be in this position.
Yeah, you'll see sort of this on commercial ships too.
Mm-hmm.
The crew, the places where the crew lives will have drop ceilings or something similar,
yeah.
which can be a real pain in the neck with the way they put it together. But
yeah,
once you move away from the house area, they don't spend the money.
Yeah, Navy ships as a general rule just don't have it at all. And I want to say that at one point they had some stuff on submarines because, they don't do it for aesthetics. They do it for sound deadening. And so, submarines want to be quiet. You've got a bunch of people in close proximity to each other, some of whom are trying to sleep because you're a 24-hour-a-day shop, but, sometimes people have to sleep. So I can understand why you'd want to put sound deadening. But there were instances where they had a damage control problem. They had a pipe leak and they had to just sort of rip down their ceiling in order to find it. And finally they said, you know what, this is dangerous. We're going to not do that. So compare this to Star Trek, where everything is behind a panel, including phasers and shit. Everything is behind a panel. You walk down the passageways and they're nice and clean. And if you ever did Star Trek The Experience, there's one where you're walking down something like that, and it's all intended to be panels that opened up and had gear behind it. It sort of makes me wonder how exactly you figured it out. Now, they did have little tags on them that if you were up close enough to actually read them, they were all jokes. Because the camera didn't pick them up. They didn't ever focus on them. It was just jokes. And it's sort of like in the way that one of the things on Dr. McCoy's, the thing above the bed that gave you all the vital signs. If you could get up close and read it, it said medical insurance coverage remaining. Okay, so here's a little bit of engineering. On the far left-hand side, it's hard to see, and I thought I had a picture of the cables that went along with it. What that is three-phase power, right?
Yes.
And so you've actually got 9 holes there labeled A, B, and C. And the idea is that you can run 3 cables that do 3-phase power. They're patch cables, right?
Yeah.
So you've got like a 50-foot long cable, and you need to patch this to that so you can patch it to run power. In the event that there's a break in between.
Yeah. They're using 3 cables per phase for ease of use.
Okay.
Okay. So you probably don't have a photo of it, but if you go up on the main deck, you'll have seen the shore power cables. They're roughly the same size in diameter, but it's a single cable. You measure it. You need 2 or 3 people to even move it across the deck, let alone any distance. With these cables here, one person can run a single cable because it's probably only 3/4 of an inch in diameter, if that. So basically it's a giant welding cable. With specially marked and plugs and bing, bing, bing.
Yeah, it looked like you could do it really, really fast. Now, Okay, so that hatch on the left there, I think that's that hatch.
Yeah, it should be. That was as far as we were allowed to go because of environmental concerns.
Yeah, the air quality down there is not real great. So we couldn't go all the way through. But that's why that hatch is not as dangerous as it looks, because it's actually got this plexiglass cover over it. And it's a scuttle escape hatch from the engineering spaces down below. And so there's a picture looking down. When we were down in the space, I took my camera and I stuck it like that and was able to get actually a pretty good picture. I was surprised at how good a picture I was able to get out of it by just sort of blindly sticking my camera in and taking a picture. And that's because it was going to be a little bit hard to get into, and you couldn't really get underneath it like that. And so I took a blind picture and it worked out really well. But that's what the other side of that ladder looks like. So that's what, 2 decks, I think? Maybe
3. 3, I think. At least 3.
It's a tall ladder. One time I was on board an aircraft carrier in the bathroom on the 03 level, one of the Nimitz's, and there was a scuttle hatch like that open in the deck, which was, oh my God, kind of dangerous. And I looked down and there was something like that. And at that point I was reminded of the fact that I was on like the top floor of an 8-story building. And that I never really went all the way down to the bottom, because I could look down and I could see like something like that. And it's like, oh, this is tall. Okay, so another engineering space. That first picture on the left is actually not in engineering. That is in the wardroom. That is the docent giving us a brief lesson on how a steam plant works, because boil water, and then you have to cool the water down again, right? You run the steam through a turbine, you cool the water down, and then you bring it around and you do it all again. Down in the lower left-hand corner, there's a picture of the circuit board, the power board, and we weren't allowed to get anywhere near it because it was actually live. All the electricity in the ship, all those lights, etc., were running through that board, and so we weren't allowed to get anywhere near it because it was potentially dangerous. In the middle up top, you've got a picture of the throttles. That's a throttle for the one screw from the one engineering space. So you've got a boiler room and an attached engine space with the steam turbine, etc., that powers a screw, and it has a throttle. And so that's the throttle for whichever boiler, whichever engine room we were in.
Yeah, it was. I can't remember which number. I think it was port forward.
Yeah, I think that works for me.
Yeah, that would have been number 2.
Down below that, you have a picture of Mike DiCarlo, and that's, I believe, we are at the lowest level of the ship. I think we're about 2 feet above the keel at that point. Upper right-hand corner, you've got the that's a turbine, isn't it?
Yep, main propulsion. That's the low pressure version.
Yeah, there's a low pressure and a high pressure because we want to get every last bit of energy out of that steam. So you run it through the high pressure one, then you run it through the low pressure one, and you've got a complicated gearing system. So you've got the turbine on the left, and then on the right you've got the gearing system, and then down below you've got a close up of the gearing system. And they've got the hatches open on some of those gears, which anybody who's an engineer who has any idea of how expensive a reduction gear is walks by that and goes, "Oh my God, I can't believe that's open." It's just amazing that
it is neat to see, though.
It is neat to see, but you can tell that the expectation is this ship is never coming back into commission, because this is something where, like, you drop a paper clip in there and it could do a bunch of damage.
Yeah. Upper right-hand picture, you can tell that it's the LP turbine because you've got 2 steam lines coming in. One is for the crossover from the HP turbine for a head, and the other pipe is for high-pressure steam coming in to do astern operations.
Oh, okay. If you need to go backwards. Okay.
Yeah. Yep. You turn one of the turbines backwards.
So one of the things I did not say is we were really lucky on this trip. The one that Peter and I did is that we had. So first of all, we had a really good docent, and second of all, Peter studied the Iowa propulsion plant when he was taking his steam course in undergrad. He went to a Merchant Marine Academy, and so he's actually, at least, some number of decades ago, knew this plant backwards and forwards because it was their case study. And so the docent was pretty sharp, not a marine engineer. And so there was places where Peter was basically telling the docent what all the different things were, etc. And the docent's asking Peter questions about how it all worked, because he had things like that, like the high pressure steam for reverse operations, that sort of stuff. So it was a fantastic tour. Okay, so let's talk a little bit about science fiction, and I'm going to really kind of focus on the fire control aspect of it. We sort of saw the engineering aspect of it last time, not last time, the time before that, when we were talking about the steam plant on the ship that Peter's currently on. That Iowa class steam plant, each one of those boiler rooms and each one of those engine spaces had, I think we figured out it was probably 40 people for each one.
All right. So for just the boiler rooms, they had 117 people assigned to the boiler division, 4 boiler rooms, 3 watches, figure 9.75 people per watch.
Okay. So 117 covered all 4 boilers.
And 3 watches, plus whatever they were doing for any kind of day work.
And then you had, 117 people just for boilers. Then you had however many in the engineering spaces, and then, you know, all throttlemen, et cetera, et cetera. There was literally one guy in the boiler space, very junior guy, whose job it was to look at a valve, look at a little glass tube. He wanted it to be half full of steam and half full of water, and he just sort of adjusted a valve to make sure that it stayed that way. And he was doing that in 110 degree temperatures. Just adjust it back and forth and keep it. So very, very manually intensive plant. The same plant today on a merchant ship like Peter's got, which not that they had the exact same type of plant, but, you know, a big steam plant on Peter's ship has how many people on watch? Two. And 3 watch sections.
Yep.
So 117 just for the boilers, not including the engines, versus 2, or well, versus 6 for all of it.
Yeah.
Star Trek is a lot closer. Most science fiction is a lot closer to the modern computerized system than it is to this. In fact, merchant engine rooms are frequently unmanned.
Yeah.
When they're actually out in the open ocean, they don't necessarily need to have somebody down there. So from a science fiction standpoint, engineering looks more like the current days than it does World War II. Fire control is interesting. Usually fire control in science fiction, I would argue, is just kind of assumed. You don't really hear anything about it. You certainly don't hear about creating the firing circuits by turning the rotary switches. There's no real equivalent of that I've ever encountered. There's no manually adjusting targeting information. It's usually something automatically gives it and puts it in. Now, there are exceptions to that. Star Wars, okay, you know, boom, 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 boom. I don't do Star Wars in this because I don't think Star Wars makes any sense. I don't think there's anything to learn from Star Wars in that regard. And automatically matching weapon to threat and stuff like that. And that stuff is really kind of what modern systems do. Like Aegis is, today's USN is almost as sophisticated as science fiction is in that regard. In that it will automatically match to threat. It automatically sort of picks which weapon to use and you know, which director and which radar, et cetera, et cetera. As of late, data links have gotten to the point where they're really pretty close to what you would expect to see in science fiction. I've often said a science fiction data link, like data links in the Honorverse, work the way that you would think that modern data links work if all somebody did was explain to you what a data link is. You know, oh yeah, all the different ships see stuff and they put it into a common operating picture and now everybody can see it. Well, the thing is that up until recently, and by recently I mean like 15 years, you were really talking about track quality data versus targeting quality data. And so what's the difference between those? Track quality data will tell you approximately where something is, but it's not good enough to fire off of. And the analogy I use is that if you're with a buddy and you've got binoculars, your buddy might say, look in the tree over there. And you put the binoculars up and you look in the tree. So he spotted something and told you where to look. But you still had to adjust the binoculars yourself to look in that location. Targeting quality data is the equivalent of your buddy giving you very, very precise directions on where to point your binoculars, as in up 2 degrees, left 3 degrees. Okay, now you should be looking at it. Yeah, that's not how that works, right? It just isn't. Except modern data links can get you to that. Between cooperative engagement capability, which lets one Aegis ship pass targeting quality raw data to another Aegis ship who then processes it using their onboard processor with whatever offsets, because you know they're looking from different angles, right? It calculates the offset and it can actually shoot off of somebody else's track. Before that, It might be that my launcher's working fine, but if I can't see it on my radar, I can't shoot it. Now with cooperative engagement capability, I can shoot off of somebody else's radar.
And the Army's working on that too, with, for example, using drones for fire control and finding targets for artillery, and enabling that remote sensing for engaging targets.
Yeah, and it's harder than it sounds to sort of get things sort of, and you end up with things like different systems have different fields of view, and now you have to make sure they're calibrated. Whereas before you could just sort of say, okay, it's a little sloppy, but it's good enough. I just need to paint the target and the thing will find it. So it doesn't matter if it says it's 17 degrees versus 19 degrees. The important thing is that it's actually putting radar energy on the target, and the semi-active seeker can see that and go home on it. Things like that. Nowadays, now you're at the point where you have to give very precise directions if you're shooting off of somebody else's track. NIFCA, Navy Integrated Fire Control Counter-Air, basically extends that cooperative engagement capability up to include the E2 Hawkeye. So now the AWACS in the sky the ship can fire off of what the E2 is saying without ever having to turn its own radar on. And so the US Navy has finally upgraded their data links to what you always thought their data links could do based upon the one-sentence description of a data link. Star Trek kind of sends mixed messages in this regard. And then it looks very manual, especially in the original series, which is always a problem child. One Horse made some comment about having, I think it was him, that talked about there being the TOS Constitution class had a phaser control room to replicate that. And so, it always was very manual. You had Kirk saying, not yet, okay, fire. And Sulu would push the button, which is just kind of ridiculous. I think there's more going on there than was apparent at first. Sulu and Worf are probably giving the ship permission to fire. It's probably all automated, and what they're really saying is like, yeah, go ahead and take your shot. But they're not aiming it itself. They're prioritizing targets, etc. At least that's my headcanon.
Yeah. Even if you were doing it with 1960s tech, with the plotting room, the bridge is now saying now you can fire, as opposed to, I don't know how they did it during World War II in Vietnam, whether they needed permission to fire each time, or if it was, okay, weapons free, go. And then whoever was down the plot.
You probably got a main battery release order from whoever the cognizant authority was. And at that point, it's fire for effect until they're told to stop. Yeah.
Which for those kinds of battles makes a lot more sense. For Star Trek and drama, put it up with the hero character.
Yeah. So, okay, let's talk about the Yamato briefly.
All right.
So, this is stuff I literally discovered this afternoon and early evening, because I got that book. In fact, it's sitting right over there, about the battleships Yamato and Musashi, and it's just chock-a-block full of drawings. I'm not going to show you any drawings from the book, but it's chock-a-block full of drawings. And I got it in part because the Yamato has this cool hangar complex at the end. But I didn't know that it also had this cool boat bay, and the rudder sort of caused me to go like, what? When I saw the rudder complex too. And so let's run through these real quick, because they're cool, and we talk about cool stuff. And, later on, this was turned into a starship, so it counts, right?
That's what's really important.
Here's sort of a beauty shot of the stern. You see the catapults with the planes on it. And you can see an interesting structure. Basically, if you look at the flag and you go down to below the main deck, you'll see there's this recessed area. You can't quite see the hangar complex there, but you can see that recessed area, and you certainly can't see the rudder. But this is just a nice beauty shot. I thought it was a good place to start. So let's look at the hangar. So they had this recessed hangar where they would lower airplanes down into this area, and the doors would swing open and they can move it inside, and they had multiple levels there with repair bays that they could use to repair the airplanes, and they could close those doors to protect them from the blast of the main guns. They calculated that they couldn't have the airplanes out because they would get all jacked up when they fired the main guns, especially if they were firing them aft. So the idea is that you put all that stuff away, and then you had this elaborate track system to move airplanes around. So, and you got the two catapults that are sort of those lift things that look like they turn. And then you've got this track system, and every place where you see a circle, that's a place where the little trolley can move onto it, the little train car can move onto it, and that circle will rotate to put it onto a different track. And then if you look on the left-hand side, you can see sort of the recessed hangar area. Towards the back, you've got a crane that can lower them into that open area in the back. And then there's a piece of deck removed so that you can see where they end up. And also note on that left-hand photo, you look in the lower right-hand corner, you can see boats. So we're going to talk about the boat bay. So the boat bay is that weird recessed structure. And if you look on the right-hand side, you can see the two photos that show the boat bay door open and the boat bay door closed. And there's an overhead track there that you can use to roll the boat out and then lower it into the water. And if you look in the lower left-hand corner, that's a model of it, and it shows a boat being deployed. Now, I don't have a good feel for how big this is. Certainly not big enough to be like a torpedo boat, but when I talk about Le Foudre, I'm going to talk about Le Foudre had really crappy torpedo boats. They were small and slow and had shitty seakeeping capabilities and barely had a weapon. But that's an interesting thing there, is how big a thing could you deploy like that? And I look at that, and that's just so cool. I thought that was really, really cool.
Looks about the same length as a little bit shorter than the gun barrel. Maybe three quarters.
Yeah, about 3/4 the length of the gun barrel.
Yeah, so import boat for taking the crew ashore or the captain is needed.
Yeah, it's about as long as that. That's an aircraft you have there, right?
About as long as that airplane.
Yeah.
So if you were you might be anchored out in the bay. You might not be pierside, in which case you've got to have boats going in and out all the time as people need to go ashore to bring parts and stuff like that. So usually ships carry a fairly large number of boats. And in U.S. service, I mean, when we were walking around on the deck of the Wisconsin, we were walking by boats that were there were places where they were pretty tight in there. And it's a battleship, and you've only got a space about 4 feet wide between the boat and its davit and the superstructure to walk through. In this case, they don't store that stuff up on deck. They store it down below where it's also protected from blast, which I thought was pretty cool.
Yeah, I think it was one of the Dr. Clark's channels. Maybe it was Drax. When the British, and maybe the United States too, when we sent our battleships to war, one of the things we did was we got rid of most of the boats that were stored that were on board, because they were just going to become fire and splinter damage.
Yeah, that can happen. So Stephen Ross says, I'm continually dismayed over all of the remaining battleships that are going to waste because we're not converting them into space battleships. Right there with you, brother. Right there with you. And so the last thing is the rudder. So you can see it's got two rudders, but in the weirdest thing I've ever seen, the rudders are not side by side. What you've got is the main rudder, and then directly in forward of it, you've got the auxiliary rudder that's about maybe half the size of the main rudder. And that's from an ad for somebody who was 3D printing these things. So that's what they look like. And you can see them. You've got a main rudder, and directly in front of it, you've got an auxiliary rudder. And that's just, I've never heard of anything like that. That's crazy. So why am I including this? I mean, it's cool and all, right? But you can't actually go and tour. We didn't tour it. You can't go tour this thing, right? Well,
Yet.
You mostly can't tour it. But you can go look at a 1/10 scale model of it. Now, the Iowa class is 887 feet long, and even though the Yamatos are displaced more, they're actually a little bit shorter. So let's call it 850-ish. So this is an 85-foot long model. And the website where I found this, there was lots of more in-depth pictures. I mean, there's probably 30 pictures of it from various angles. I picked these two because it gives you an idea of exactly how big this thing is. And the way they've got it set up is that you've got a ramp. It looks like you've got a ramp that goes up one side so that you start off like way underneath it. And by the time you get up to the top, you're looking down on the deck, which is actually a very nice design. So you can see it both down low and up high. That's a pretty cool model. I need to know next time if I ever go back to Japan, I'm going to Kure to look at this model. The closest I've gotten is when I was on base at Yokosuka. The Yokosuka is where the Yamato class ships were built, and the cranes that they used to build them are still there. One of the cranes is named Godzilla, and I can't remember what the name of the other one, but I want to say it was like Mothra or something like that, right? It was another movie monster name. And the cranes are still in use. So, and that's it.
Well, that's pretty neat.
Yeah.
That model is a little bit smaller than a basketball court. So that's how big that thing is.
And I think it is the case, if I remember correctly, the two torpedo boat sizes of PT boats that we used in World War II, one was 110 foot and one was like a 90 foot, if I remember correctly. Might have been more 90. It might have been like 95 or 98, but it was that order of magnitude. And so that model is like torpedo boat size. Modern torpedo boats, right? And by modern, I mean World War II. But it's at some point I'm going to talk a little bit more. I want to do a thing on torpedo boats, and that may be next week. I'm not sure. I also want to do something on, like I said, naval treaties. That's on the list of things to do. I want to go back and revisit battle lines versus battle groups, because I don't think that presentation came off the way I wanted to, and I've been doing some more thinking about it and about, what is the important part about switching to aviation in World War II. And I would argue, people focus on airplanes and stuff like that, and that's a big deal. Don't get me wrong. But I think one of the things that gets short shrift is the tactical flexibility you get from being able to aggregate and disaggregate your forces in a way that you just can't with a battle line. And so I'm going to explore that a little bit. So I think that I don't have anything more to say. Sean? Yeah. LYSSA just turned her camera on. You can't see it, but LYSSA was like jumping for joy because we're at the hour and 24-minute mark and we're about ready to stop.
Look, we officially say that it ends at 11, but it never goes to 11. It's always like 11:30-ish every time.
So when I took when I did the degree at the Naval War College, the instructor explained that at one point they said the class lasts 2 hours and 45 minutes. Mm-hmm. They used to say it was 2.5 hours, and they get people saying this is horrible. We always go 15 minutes long. Mm-hmm. And changed the description to say it lasts 3 hours, but they still finished at 2 hours and 45 minutes. And then people would write on the review form, oh, this is great. It's a 3-hour class, but they always finish 15 minutes early. So it's all about perceptions. So I think I'm going to just officially declare that Starfleet Tactical is a 2-hour long show. And we'll just finish early each week. So, all right. So, Sean, any final parting thoughts?
No, other than what I said before about anybody who's interested in battleships, go see the other ones too that are around, like the Massachusetts, like the Alabama, like the Texas. They're different, and they're a lot of fun to see.
Yeah, I haven't done North Carolina and I haven't done Texas. I have done the 2 South Dakota class ships, the Massachusetts and the Alabama, and you can see a lot more on those ships than you can on the Iowas. There are spaces that are open that you can go into, like the lower turret area and see all that stuff, and you just can't do that on the Iowas. So in part because those are they've been museum ships since like the early 60s. And so they've had a lot more time to sort of open up the spaces and get their act together and stuff like that. You can't just open up a space, right? There's all sorts of prep work you have to do. You have to make sure that there's padlocks on the things that there needs to be padlocks on, et cetera, et cetera. And so I feel for the guys at the Wisconsin and the other ships, because they just haven't had them as museums for very long. And, that's why I always drop an extra 20 in on my way out. I pay for the tours that are like, $40 a piece, and then throw extra money at them on the way out, because that's what they're doing with the money. They're trying to use it to open up areas that you can't get into yet.
And folks going around cleaning up stuff and putting on the padlocks, etc.
Yeah, and making sure that all the sharp edges are filed off. And there's lots of stuff where they have to like, naval vessels aren't particularly safe, and they've gotten safer over time. So in 1940s era naval vessels, not particularly safe inherently. And so they have to make sure that it's better than it was, right? Peter, any last thoughts?
No, I think we're good on for this set of ship tours at the moment.
So, okay. I agree with that. And I'm looking and see if there's any last minute. There's lots of discussion here, but I don't see anything that I need to respond to, so I'm not going to. But I am going to say that, as always, I am very pleased that you all chose to spend your Saturday evening listening to me and whoever I pull on the show talk. I really, really appreciate that. And I look forward to doing it again next week. And in the meantime, live long and prosper.